Hello everyone, good morning. Finally, I am able to take this session with you, which is going to help you to answer geometry questions not only in IOQM, forthcoming examination IOQM, other Olympiad examinations also. But I am here not to solve only Olympiad level sums. One introductory session has to be there. Today's session I kept for discussing introductory part of circle only, because in my group some students are there, they are competing from class 8 also. But at the same time, I'll tell you what you do in normal class, CBSE classes, that kind we are not going to do, although I'll take some example from exemplar books. But our aim is to learn the topic very first and then to apply to solving problems from IOQM papers, past year's papers, and then for other Olympiad examinations. And this session I am going to explain everything in details. Okay? Hardly I will get time to solve very difficult sums here, but I will try my level best to do that. So let us start. This is Introduction to Circle Part 1, main concepts and result. I am going to explain circle, radius, diameter, chord, segment, and what is cyclic quadrilateral. So this one is a circle. It is locus of a point which moves in such a way that its distance from a fixed point is always a constant. Then locus of the point is a circle. So this is the center of the circle and this is radius. Movable point is there, it is moving on the circumference, and its distance from this fixed point will remain the same always. Anywhere you go, this distance, this one, all these will not change due to motion of the point. So locus of that point is a circle. When this circle moves, then area is described at the center. If it goes from the point A to the point B, then this sector is formed. It is some area which you are doing normal CBSE class. If the circle radius is R, you write area of the sector. This sector will be what? Area equal to this angle. The angle it makes at the center with theta. Area is theta by pi r square, theta by 360 degree into pi r square. Theta means if it is 30 degree, 30 by 360 into pi r square. We are not going to discuss all these things which you have done in class 9 and 10, but I have to remind you. Today I promised that I will explain from beginning, because this class is for all, not only Olympiad solving problem. First class cannot be that. I have to tell you the concepts. Segment, chord is where? This is a chord here. In this diagram you can see that this is going to be a chord here. If we name this one as A dash B dash, this is a chord. We can join these two also to get a chord which is AB. Okay, these are all chords. But if a chord passes through the center, then it will be diameter. That's why this one is mentioned as diameter. This is an arc AB. This arc we denote by this symbol. This stands for arc and this one stands for chord of the circle. Okay, circumference is formula you have done, some of you done sums based on it. Pi is equal to the ratio between circumference to diameter. Circumference to diameter, this ratio is called pi. C is the circumference, D is the diameter. This ratio is called pi. Segment which I was telling you, that may be major and minor. This portion is the minor segment because area is minor, that's why it is minor segment, and this part is the major segment. And one basic concept I would like to discuss with you before we jump into the concepts and theories, that construction of circle. If you have 2 points there in the plane, how many circles can be drawn? Only one or many? To these 2 points, many circles can be drawn. How to draw that circle? If you join these 2 points, then how many circles? You told that many. I told that many circles. How? You draw a perpendicular bisector here. A and B are 2 given points. Okay. Take a point C here, C1 here, and then by taking C1 as the center, circle can pass through these 2 points. Oh my God, this is not a circle. This has taken the shape of ellipse. Okay, but just a minute. Oh no, this is not going to be a circle. I take the help of technology here, because then it will take long time for me to show you one circle only. Just a minute. I take a shape here. Yeah. How did you get this circle? This I tell you. This circle is there. How? There was a chord here of the circle, or we have a line segment AB. We have drawn perpendicular bisector. Center of this circle will lie on the perpendicular bisector. We can draw many circles just by changing this center. Center is here. Center I can take here also. Then I can get another circle. Okay, how to? Just to move it bit. Obviously this center is changed. Center is at say C1 here. It is changing. I can draw many circles through these 2 points. Circle might be of this form. Center lies at different place. Okay. So by joining 2 points we can get many circles. But when you have 3 points given over there, we can draw only one circle. What is the concept? You take this line segment ABC. Join these 2 also. Now there is a perpendicular bisector of this line segment. Center of the circle passing through these 2 points will lie on it. Similarly, draw a perpendicular bisector of this line segment. Center passing through these, circle passing through these points will lie on this perpendicular bisector. Okay, here also if you draw, you will get a perpendicular bisector of the sides. They will be meeting at a point, and then you can draw a circle passing through these 3 points. Okay, that is called circumcircle. So through 3 points you can draw only one circle. Through 2 points you can draw many circles, but through 3 points one and only one circle can be drawn by remembering this concept here. Okay, this is very important theorem for those who have just completed class 9 or studying in class 9. Through 3 points, one and only one circle can be drawn. But it cannot take much time to discuss all these things. Arcs I told you, chords I told you, radius, diameter, major segment, minor segment, everyone understand. Formula for circumference 2 pi r, formula for area pi r square, that also you know. Now I have to tell you some concepts very first regarding circle. We cannot make this one a class for solving NCERT problems only, textbook problems only. NCERT is a nice book. Myself, when I get time, I study NCERT books of many subjects, not only one subject. Okay, because NCERT books are written by eminent scientists of our country. So everyone, teacher, student must go through those books. Don't laugh at me, because really it is important for me. But this class, as NCERT you are completing in school, no, not here. So equal chords of a circle subtend equal angles at the center. This is a theorem here. Proofs are also possible. I am just telling you, AB, this one is a segment. Okay, this one is a chord. You take another one, segment and chord. Okay, this chord is equal to this chord length. They are equal. This arc length, arc AB equal to arc CD, or chord AB is also chord CD. Then at the center of circle they will subtend equal angles. It's very easy to prove. Anybody can do it by using congruency of triangles. Join this. This you have taken center of the circle. Join these two also. Okay. This thing equal to this thing. Both are radii. This thing equal to this thing. And this is equal to this. So these two triangles are congruent. So this angle must be equal to this angle. Equal chords will subtend the same angle at the center. Clear? Next one. If the angles subtended by the chords of a circle are equal, then chords are equal. Again, by using the converse of this theorem, you can prove that. These are all theorems studied by students of class 9. Perpendicular drawn from center of circle to the chord bisect the chord. Okay? Perpendicular drawn from, this is also very easy to prove. So one thing I have to make clear, this one is a chord definitely. AB is a chord. But if you write AB here, this is not a chord. This is going to be a secant. You must be familiar with these terms. So this is a chord AB. Perpendicular, if you draw from center, then you can prove these two triangles are congruent. OAB, this is congruent with this. From there you can prove that AM equal to BM easily. Okay? Line drawn through center of circle, just converse of the above theorem. Okay? If there is a line and there is a chord, this is a chord AB. Sorry, this is not chord. Just I told you it cannot be a chord. Isn't it? It is a secant. This one is a chord now. If there is a chord and a line drawn through the center bisecting it, this thing equal to this thing, then this angle has to be 90 degrees. This you can prove again by congruencies of these two triangles, OAM and OBM. Next one, there is one and only one circle passed through three given non-collinear points that I told you. Through 2 points you can draw many, but through 3 points you can draw only one circle. Equal chords are equidistant from center. Again, this is the application of the theorems I have already mentioned here. These are two chords AB and CD. Center here. From center O, if you draw the perpendicular OM1 and draw another perpendicular here OM2, then this must be equal to this. Again, it can be proved by congruency. I just remind you here. Okay, if you want to prove, you do at home. Next one, two chords of a circle are equal, their corresponding arcs congruent, and conversely, if two arcs are congruent, then their corresponding chords are equal. Very simple, very easy. Go for next one. Congruent arcs of a circle, same, whatever statement I am giving you, with the help of theorem 7 I just told you. If AB equal to CD, then arc AB must be equal to arc CD and vice versa. And if they are equal chord, they will subtend same angle here. So you can say that arcs also subtending same angles if they are of equal length. Angle subtended by an arc at the center is double the angle subtended by it at any point remaining part of the circle. There is a chord AB, AB is a chord over there. This is the center O, and P is an arbitrary point. You can take it anywhere. P is an arbitrary point on the circumference. Then you can prove that angle AOB will be 2 theta, twice angle APB. It can be proved very easily. Okay? You just take it here. This position you just change. Position of this point you just change. You take it here. I'm just giving you a proof this manner. You just join it. Okay? Then you can prove that this angle here, just a minute. Yeah, you can prove that if this one theta, this will be theta, this one theta means this is also theta. So angle AOB will be 2 theta, that is twice angle ABB. This is always true. Chords also it is true. Next one, angle in the same segment of a circle are equal if a line segment joining 2 points subtends equal angles at 2 other points lying on the same side of the line containing the line segment, then 4 points are concyclic. Okay? There's something more I have to tell you here. Cyclic quadrilateral, let me explain. And some, I did not get time to write all those facts. Whatever I am not able to write, that I will explain here. Four vertices will lie on a circle, then this one is a cyclic quadrilateral. Cyclic quadrilateral. For a cyclic quadrilateral, you can prove that this angle plus this angle alpha beta, or this gamma and delta, their sum will be 180 degree. Can be done easily. And gamma plus delta is also 180 degree. How to get this? This is the center of the circle. Okay? Just to join this also. Just a minute. Join this also. Now this angle will be what? Twice gamma. This angle will be twice delta, but this total angle is 360. So 360 going to be twice gamma, twice delta. So this implies gamma plus delta 180 degree. Similarly, you can prove alpha plus beta also 180 degree. Okay. So this is a cyclic quadrilateral. For cyclic quadrilateral, sum of two opposite angles, I mean two vertices opposite, their angle of sum held at those points, their sum will be equal to 180 degree. Okay. Now let us start from the end. I have taken two or three problems here. Let us discuss some figure questions I have taken from NCERT exemplar book to start the topic. Okay. Let us start this one. O is the center of circle, and given that BCO, you can see the diagram. Okay, angle BCO equal to 30 degree. Find the values of x and y. I hope all of you can start this one. You can see this angle is 90 degree here. This angle is 90 degree here. You all can try. Just go for that. Finding the values of x and y. This angle 30 degree. This one 90 degree. So this angle has to be 60 degree. Isn't it? Now you can easily prove that if you join this, then these two triangles are congruent. This is equal to this. If this one 30, this 90, no, that's why perpendicular, if you draw, it will bisect. And this triangle is 90 degree. So if you take this point M, then in this diagram OBM must be congruent with triangle OCM. So this angle 30 means this one also going to be 30 degree. This angle 60 means this is also going to be 60 degree. Isn't it? Now, if you have got this angle and you see this radius is also equal to this radius, if this one equal to x, this one has to be equal to x, isn't it? So now you have got one information to get the values of x and y. That is, this one x, you have taken this one x. So in triangle ABM, what have you got? X plus x plus 30. Why? This is x and this one 30. X plus 30 plus 90 equal to 180 degree. So 2x is 60 degree. X I got 30 degree. Now you need to find the value of y also. Value of y can be determined easily. If you got this one 30 degree, I mean no, this one not 30 degree. If this total angle BCO is 30 and this angle is 30, don't do mistake. This one 30. Okay. Now this angle 90 means this is 90, so this part going to be 30 degree. So this chord CD or the arc CD make 30 degree at the center. So the value of y, this one is y only, it has to be half of it. Am I correct? Angle at the circumference, half the angle at the center. So y will be 30 by 2, 15 degree. To start anything, textbooks are very important. Those who are studying class 8, they can go through class 9 circle problems, because in any Olympiad question, as my observation goes on, more or less 1/4 of the question paper will be on geometry. To excel in geometry, you need to do class 9 and 10 syllabus. Class 8 introductory level, you got some idea only, but class 8 doesn't help to qualify Olympiad exam. Class 9 and 10, these two, those who are in 9, they will solve it from class 10. You start with textbooks. Textbooks means I'm talking about NCERT and exemplar book. Do them, and next session I will be coming with Olympiad exams. Olympiad problems. Definitely I will discuss. But before that, again I have to remind you class 10 theorems. This the theorem I told you today. It is basically class 9 books. It is there. If you go through class 9 books, these theorems you will find. Okay? Then class 10, you have to do all these things. Then only you can approach for Olympiad sums. No, basic fact if you forget, then you won't get. An IOQM exam, class 9, 10 syllabus, geometry sums you do properly, then you will excel. I am telling you today. Okay? Advanced concepts are definitely there, that will do, but go step by step. Okay, then go for this problem. In this diagram, O is the, again NCERT exemplar problem. O is the center of circle, BD equal to OD given. CD is perpendicular to that. Find angle CAB. Okay? Can you try first, then I will help. One important information is there, that BD is equal to OD. BD is equal to OD. Okay? BD equal to OD. There is a catch. BD equal to OD means BD also radius. So in this picture, what do you observe? OD equal to radius. That is equal to OB. Now you said OD equal to BD. Given over there. So this implies triangle OBD is right angle. Is equilateral. This is equilateral. Okay? All angles are equal to 60 degree. So this part is 60 degree. Okay? Now you can find CAB easily. How to? For CAB, we need to know the angle made by the chord at the center. Are we able to get it if you join this? Can you find this angle? Then everything is done. Isn't it? Can you get that angle? For that, you check whether you can do that OBC congruent with OBD or not. If they are congruent, then it's fine. Are they congruent? Are these two triangles congruent? Of course they are congruent. Because if you have taken, let me make this diagram a bit bigger. Yeah. These two are congruent triangles. Triangle OCM congruent with triangle ODM. Why? Because these are radius. No, this is equal to this. This angle 90. So vertically opposite, this is also 90. So these two are congruent. OM is common. If they are congruent, then it is proved. DM equal to MC. Then this is also proved that this is 60 degree. Which one? Angle COB 60. What about angle CAB? This is going to be 30 degree. Is that clear? Understood? Now go for this one. Two equal chords AB and CD of a circle when produced intersect at P. Prove that PB equal to PD. I don't know from where I have taken. Maybe this is also exemplar book problem. Okay, this introductory class, better we don't do very difficult sums. Okay? You try, you read, draw it, then I'll get back to you. Start. Read the sum. Two equal chords AB and CD of circle when produced intersect at P. These are two equal chords AB and this one is CD. They intersect at P. Your problem is to prove that PB equal to PD. Okay, try to do it. Just this is the diagram here. These are two equal chords. AB is equal to CD. You have to prove that PB equal to PD. So simple. You can prove it easily. Equal chords subtend equal angles. This you know. Okay. So this is center. All these equal. These two triangles congruent. This angle is equal to this angle. Can you prove that this triangle, I mean APO congruent with CPO? If you can prove that, then it is done. You just try to prove that, because you have to prove PB equal to PD. If you can prove that PC equal to PA, then everything is done. You try to prove PC equal to PA first, then it will be done. Okay, just try once. There are various ways. You can think this way also. This is the circle. These are the chords. This is the center. You draw perpendiculars. draw perpendiculars. We often do this. From the center you draw perpendicular. OL and OM, and then join this. You can proceed this way also. Okay. Now length of radius will be the same. I mean this thing equal to this thing, this angle 90, this angle 90, and OP is common. So triangle OLP congruent with triangle OMP. So what is your conclusion? This implies that LP equal to MP, isn't it? But still it is not proved that DP equal to PV. Now what you are going to do, just think about this diagram. You know, class 9 theorem, if you draw a perpendicular, it will bisect. These two are equal. These two also equal. So they are all congruent. So you can say that MB equal to LD. Now from LP, whatever you got there, from LP equal to MP, this is number 1, you got LD equal to MB. Number 2, you just subtract LP minus LD equal to MP minus MB. LP minus LD is what? This is DP and this one PP. So DP is equal to BP, or PD equal to PP, or PD equal to PB, whatever you say. Done? Now go for next one, that AB and AC are two chords of a circle of radius r such that AB equal to 2AC. This is also exemplar problem. Okay? If P and Q are distances of AB and AC from center, prove that 4Q square equal to P square plus 3R square. One thing I would like to tell you today, no exam conducted by group of people, those are actually working in organization of Government of India. Remember, all these projects are taken by Government of India only. So Olympiad examination, whatever conducted in India, IOQM, RMO, INMO, Physics Olympiad, Cyber Olympiad, Office of Central Government is involved. And in VVM exam also, they always say that textbook based question will be there. Although RMO, INMO, you are going for a, you have qualified INMO means you are gradually going to the RMO level, then INMO level, then International Maths Olympiad. So there you don't expect anything which is a direct application in your textbooks, even RMO exam. But the qualifying round, it will be based on the concept given in your textbooks. Okay? So any subject, any examination conducted by the offices of Government of India, it's your duty to do NCERT books properly. Not only NCERT main book, exemplar book also. Exercise, solve examples, you be prepared first. Then go for those exams. Because when you are prepared in those now, then I am telling you IOQM paper, 60% you will be able to answer. Don't laugh. It's true. Do you know all these things? Can you do it in 1 or 2 minutes? With IOQM exam, time matters. Can you do it very fast? Just go through the sum. Check. AB is given twice AC. So draw the diagram similarly. Take a bigger one. Sorry, this is not going to be circle. Yeah, this is a circle now. AB and AC are two chords. AB equal to twice AC. Look like that almost. AB, AC. P and Q are distances of AB and AC from the center. Center is there. From center you draw perpendicular. This is OL and this part is OM. Okay, and this distance is P, this one Q. R stands for radius here. I forgot to write. R is the radius. Okay, this R is the radius. You have to prove that 4Q square equal to P square plus 3R square. You have drawn the perpendicular, isn't it? It is given that length of chords, one is double of the other. So let us take length of this chord AB. Let AB equal to 4A. Let. So then perpendicular will divide from center. If you draw, it will be 2A. And this, when you assume AC is going to be equal to 2A, so this part is A. Isn't it? So in triangle OAL, you get P square plus 4A square, number 1. And in triangle OAM, you got R square Q square plus A square. Because this is a perpendicular. If you draw from center, it will bisect the chord. So this length equal to this length. AC you have taken 2A. So this part A, this part A. This you have taken 4A. So this part 2A, this part 2A. Clear? Now, in triangle OAL, OA square equal to OL square plus LA square. So what you can write here? R square equal to P square plus 4A square. Isn't it? And then in triangle OMA, what do you get? Again you write OA square equal to A square plus Q square. Okay? OA is R only, so you write this implies R square equal to Q square plus A square. Okay? Now what do you have to relate? Q, P and R. But there is a factor A which is not allowing us to relate. So we have to do something for it. What you are planning? We will make A square subject of R and P from 3 A square equal to R square minus P square by 4. And from 4, isn't it? So this one and this one. Now these two together will imply what? A square can be compared now. r square minus p square by 4 r square minus q square. Alright, done. So now you cross multiply. And now change the side. Okay. So 3r square plus p square equal to 4q square. We have done this. Clear? Understood everyone? Now let us go for this one. We have started from the end. Just a minute. Circle has radius 2 centimeter. It is divided into two line segments by a chord of length. Two line segments by a chord of length. Sorry. Just a minute, I'll arrange it. Yeah. Circle has radius 2 centimeter, divided into two segments by a chord of length 2 centimeter. Prove that the angle subtended by the chord at a point in the major segment is 45 degree. This is AB. Okay. This chord has length 2 centimeter. Radius of circle is also 2 centimeters. Okay. Radius is 2 centimeter, 2 centimeter. By chord of length 2 centimeter divided in two parts. That is major and this is minor. Now, angle subtended by the chord at a point in the major segment is 45 degree. But at which point? That is not mentioned. Angle subtended by the chord at which point? That is not mentioned. Let me go through that NCERT exemplar book problem, then I will tell you. Just a minute, let me check it. Just a minute. I am not getting the book now, so I will correct it afterwards. What is the exact sum given? Okay. This I am not getting now. The sum I am not getting here. Just a minute. Let us solve this one here. This one. ABCD is such a cyclic quadrilateral that A is the center of circle passing through BCD. Prove that CBD, this cyclic quadrilateral problem, let us solve. cyclic quadrilateral ABCD. A is center of the circle. A is the center of the circle passing through BCD. No, ABCD is a quadrilateral. A is the center of circle, and that circle is passing through BCD. Other point they have not given. A is the center. Okay. Then you have to prove that CBD. CBD means it just joined. CBD plus CDB equal to half of BAD. Not a difficult one, you can do it easily. Yeah. BAD angle is here. This is the angle BAD. A is the center of the circle. Okay. You prove that CBD plus CDB equal to half of BAD. Okay. How to start? ABCD just cyclic quadrilateral given, and these two angles equal, it is given. Okay. Then you have to prove what? That CBD plus CDB equal to CAD. This position possible. A can have other position, that center, who told you that it will be lying there? It can lie here also, isn't it? But one thing is clear, this angle is half of this angle. Am I clear? This is half of this angle. These two angles are equal. So angle DCB is what? 180 minus 2 into 180 minus angle CBD minus angle CDB. So it is twice 2 into 180 degree minus 2 into angle CBD. Alright. This you take 2 into 90 minus CBD. Clear? 2 into 90 minus CBD. Now, sum of these two angles is 180 degree, sum of these two angles also 180 degree. Isn't it? So this BAD surrounding this CBD, this angle also will be twice this angle. This is clear? Isn't it? Now, if we take angle DAC, this angle DAC equal to twice angle DAC will be twice angle CBD. Isn't it? This is number 1. Similarly, what do you get? Angle CAB is what? Twice angle CDB. Isn't it? Now, if we add these two, just add these two equations. Angle DAC twice angle CBD plus angle CBD. What do you get? CBD plus CDB. This is 2 into CBD plus CDB is what? 180 minus 180 minus CBD plus CDB. You see, no, this diagram CBD plus CDB is what? 180 minus BCD, isn't it? So this is 360 degree, or 180 minus BCD. This part is BCD. We have to reach BAD. Twice BCD is BAD. So this will be 360 minus twice angle BCD. Twice BCD is angle BAD. Okay. So what have you got? You got DAC plus DAC plus CAB, means this angle you got. Okay, but we have to reach BAD. But you can see that in the triangle, this reflex angle and this one, their sum is 360. So from 360, if you subtract this BAD, then you are getting the required thing, isn't it? CBD plus CDB. What have you got? There you got CBD. Just a minute. DCB is 2 into 180 minus, if you don't separate, it will be CBD minus CDB. Okay, then that you got 180 minus CBD plus CDB, that is CBD plus CBD. So that 360 minus this angle is going to be equal to angle BAD. So sum of those two, angle CBD plus angle CDB, CBD plus angle CDB is 180 minus BCD, which is going to be half into 360 minus twice BCD. And we have proved that 360 minus twice BCD is equal to that sum. So this is half into angle BAD. Isn't it? Clear? So CBD plus CDB is half into BAB. So you try the other sums from exemplar book and discuss your doubts with me. If possible, next class. Probably tomorrow I am going to take a class on circle only, that I notify. There will be doing class 10 problems and some problems from Olympiad, recent years IOQM paper. Thank you for staying.